Let's multiply 4 times 80. So we can look at this a few ways. One way is to say 4 times we have the number 80. So we have the number 80 one time, 2 times, 3 times, 4 times. 4 times we have the number 80. And we could do this computation, add all of these, and get our solution. But let's look at it another way. Let's try to stick with multiplication. And one way we can do that is to break up this 80. We know a pattern for multiplying by 10, so let's try to break up this 80 to get a 10. So if we have 4 times, and instead of 80, let's say 8 times 10. Because 80 and 8 times 10 are equal. Those are equivalent. So we can replace our 80 with 8 times 10. And then we have this times 10 back here, which is super helpful because there's a nice neat pattern in math that we can use to help us with the times 10 part. So let's start to solve this. 4 times 8 is 32. And then we still have 32 times 10. And then we can use our pattern for multiplying by 10, which is that any time we multiply a whole number times 10, we take that whole number, in this case 32, and we add a 0 to the end. So 32 times 10 is 320. And there's a reason that pattern works. We went into it in another video, but here just real quickly. 32 times 10 is 32 tens. And we can do a few examples. If we had, say, 3 times 10, that would be 3 tens, or a 10 plus another 10 plus another 10, which equals 30, our whole number with a 0 on the end. If we had something like 12 times 10, well, that would be 12 tens. And if we listed out 10 12 times and counted them up, there would be 120. It would add up to 120, which again is our whole number with a 0 on the end, our 12 with a 0 on the end. So we can use that pattern here to see that 32 times 10 is 32 with a 0 on the end. Let's try another one. Let's do something like, let's say 300 this time. We'll do hundreds instead of tens, times 6. Well, 300 we can break up like we did with 80 in the last one, and we can say that 300 is 100 3 times, or 100 times 3. And then we still have our times 6 after that. So these two expressions, 300 times 6 and 100 times 3 times 6, are equivalent because we replaced our 300 with a 100. And then from here we can multiply. And let's start with our one-digit numbers. Let's multiply those first. 3 times 6 is 18. And then we still have 18 times 100, or 18 hundreds. So we can write that as 18. And then to show hundreds, we'll put 2 zeros on the end, or 1800. Just like up here, just like we saw that 300 is equal to 3 times 100, or our 3 with 2 zeros on the end. Well, same thing here. 18 times 100 is 18 with 2 zeros on the end, or 1800s. So 300 times 6 equals 1800. Let's try another one, but this time let's go even another place value and try thousands. Something like 7 times 7,000. So like in the previous ones, we're going to break up our thousands. 7,000 is the same as 7 times 1,000. 1,000 7 times. And we still have our times 7 in the front here to bring down. And again, we can multiply our single digits first, our one-digit numbers. 7 times 7 is 49. And then 49 times 1,000 is going to be 49,000, which we can write as 49. And this time, maybe the pattern's becoming clear, we're going to have 3 zeros on the end. So it will be a 49 with 3 zeros, or 49,000. Just like up here, 7 times 1,000 was a 7 with 3 zeros. 49 times 1,000 is a 49 with 3 zeros, or 49,000. Let's look at this as a pattern. If we show this as a pattern, let's do something like 9 times 50. And then in another one, let's do 9 times 500. And in one last one, we can do 9 times 5,000. I encourage you to pause here and see if you can work these out. See if you can come up with solutions for these three expressions. And now we can work them out together. 9 times 50 will be the same as 9 times 5 times 10, because we broke up our 50 into a 5 times 10. And then if we multiply across, 9 times 5 is 45. And to the end, we're going to add 1 0. The pattern for times 10 is to add 1 0. We can keep going here. 9 times 500 will be 9. And then times 5 times 100. 500 is 5 hundreds, just like 50 was 5 tens. Multiplying across, 9 times 5 still equals 45. But this time we will add 2 zeros to the end, or 4,500. And finally, 9 times 5,000 will be 9 times 5 times 1,000, because 5,000 is 5 thousands, or 1,000 5 times. Working across, 9 times 5, 45. And this time we add 3 zeros. So 45,000. So when we multiply each of these expressions, we can see the only thing that changed was the number of zeros on the end. So the pattern, anytime we multiply a whole number times 10, we add 1 0 to the end of our number. Anytime we multiply a whole number times 100, we'll have 2 zeros, and times 1,000, we'll have 3 zeros. And once we know that pattern, we can use it to help us with questions like this, where initially we don't see a 10, a 100, or 1,000, but we can get one. We can break up or decompose these numbers to get a 10, or 100, or 1,000 to help us solve the problem.